Hello and welcome to a ABAQUS tutorial. In this tutorial we will be modelling a masonry wall and subjecting it to a blast explosion. So first of all, if you click on File, New Model Database and go across to the Standard/Explicit Model. If you click on that and then come across to the model tree and then double click on Parts, I'm going to create a part. I'm going to name the part Wall. And we're going to leave everything else as it is, so 3D deformable, solid, extrusion, and make the approximate value 20 and click continue. So this will bring up the 2D sketching viewport, and from the tools we would like to select the create rectangle tool. That's what we'll use to draw our masonry wall. It's just going to be a simple rectangle, so if you just click, drag across, click again, now create the rectangle, and to dimension the rectangle use a dimension tool, clicking on the corners and then dragging across. And then if you see at the bottom it will say new dimension, but we like to keep the dimension at 3 meters, so we'll just press enter and we'll do the same again for the bottom and then click down, and then again we'd like to keep it at 5, so we'll just press enter. So that completes the sketch of our wall. So if you just unclick on the dimension tool then click at the bottom done, and that will finish our sketch for us. Now the edit base extrusion box will turn up and we're going to type in 0.215, so that's the depth of our wall, and that's the depth of a normal clay brick in the UK. So we're just going to press OK there, and that's your 3D wall. So next step, we'll have to create a material to apply to the wall. So we'll double click on materials, and it brings up the edit material box. So I'm going to type in masonry, and then we're going to click general and density and type in 2000 as the mass density, which is the mass density of a clay brick, and that's in kilograms per meter cubes. Then next we click on mechanical, elasticity, and go across to elastic. I'm going to type the Young's modulus in as 118E8, and that's in newtons per meter squared, and the Poisson's ratio, which doesn't have any units, as 0.15. It should be noted at this point that the masonry wall is being modelled as elastic. In reality it is an elastic brittle material, but for the purposes of this video we're going to just model it as elastic. So we just press OK. The material is created. Now we have to assign it to the wall, so we do that by creating a section. So if you click on the create select section, and then we leave everything as it is there, press continue, and as we see, masonry, the material that we've already created, is in there. So we press OK. Then we assign this to the wall by clicking on the assign section tool, and then we click on the wall, and then at the bottom if we click done, and then we press OK and check everything's OK. It's the masonry material, press OK. And now the wall has changed colour, signifying that the material has now been applied. So next we're going to assemble the model. So we open up the assembly, double click on instances, and then we're going to leave everything as it is there. As there's only one part, it doesn't matter if it's dependent or independent, but we'll leave it as independent, so the mesh will be on the instance. So we press OK. So once that's done, the next step is to create the analysis steps. The purpose of the analysis steps is so we can define to ABAQUS what we want to model. So as we're modeling a blast explosion, we're going to create the blast explosion here by double clicking on create step, and then in this box I'm going to type in blast, and I'm going to choose dynamic explicit because that's the best to describe a blast explosion. So we're going to, under time period, we're going to type in 0.01, which is the length of a normal blast explosion. We press OK. So if we just open up the steps, and we can see that that has now been created after the initial step. So the next step now is to create the boundary conditions of the wall. So in here we're going to type in fixed, and the important step here is to make sure you highlight initial, so that the boundary conditions are from the start to the finish of the explosion. And we click symmetry, and then we press OK, and then what we're going to do is select the edges of the wall. We're going to fix all 4 edges of the wall. So if you hold shift and select the edges, then use the rotate tool to spin the wall round so we can view the other edges also. And same again, holding the shift tool, if you just click on the edges, there we go. So now all the edges are going to be fixed, and we just spin the wall round to the original position we had it before, so we can see that all the edges have been selected. And then we press done at the bottom, and there we go. And then we're going to select Encastra so that they're completely fixed, all 4 edges are completely fixed. We press OK, and we can see now that the boundary conditions have been completed. So the next step now is to apply the load. So we're going to type in blast load, and make sure we select the blast step as well. Type in blast load, and we're going to choose pressure. because this best describes a blast load because of the waves that are created from a blast explosion. So we click on pressure and press continue, and then we select the face, so we want to apply it to the front face, so we press done. And then in magnitude we're going to enter 1, and then what we're going to do, apply the load as an amplitude. So we're going to create a tabular amplitude, which means that we can apply a linear force to the wall over a set time period. So at the time period of 0, we're going to enter the amplitude as 10, 0, 21250, and that's in pascals. And then we put the final time as 0.01, and it goes down to a pressure of 0. So then we select amplitude as amplitude 1 that we just created and press OK. So the load has now been applied to the wall, as you can see by the arrows on the front face of the wall there. The final step now is to create a mesh so that Abacus is able to analyze the wall. We're going to click Mesh Element Type and select the element library as explicit, press OK. Then the next we're going to seed instance, and what I've actually done, I've undertaken a mesh convergence test to choose the best mesh, and that's 0.04, and that's the best for this particular application. Other applications might require different meshes, therefore a mesh convergence test should always be undertaken. Smaller mesh does produce more accurate results, but it does very much increase the computational time. So we're going to choose 0.04 and then press OK. And as you can see, the seeds will now appear on the screen, so we're going to press done at the bottom of the screen to accept that. And then next we click Mesh and then Instance, and then press yes at the bottom of the screen, and this model has now been meshed. So that we're almost there now. The final step is to submit the job to Abacus for analysis. So double click on jobs, press continue, leave everything else as is there in the edit job box, press OK, and as you can see, job 1 has now been created. So if you right click job 1 and then click submit and then press OK if that dialog box comes up. So now, as you can see there, it says submitted. That means the job has now been submitted to Abacus and now it is running. So this will take a while depending on the size of the wall. So whilst this is going on, the Abacus will be analysing the wall, and in the next video we'll look at analysing the result.